Hi, algebra guys. I just wanted to, get back to talking about algebra two. Um, Time to keep moving on. Yay, moving on. We love it. So we were factoring quadratics, and before we were factoring quadratics, with nothing over here, with a zero over here, and then we were solving for zero, and then x, then we would solve for x. For example, if we had nothing over here, if it was x squared minus 8x plus 16 equals 0, we would see, and this is actually a perfect square, so we would, what times what gives you 16, and you'd say 4 times itself, and then 4 plus 4, or negative 4 plus negative 4 is negative 8, and you would say that, this is x squared, oh, sorry, not squared, boop, x minus 4 times x minus 4 equals 0, and then you would solve for x. And then you'd say it only touches the x-axis at one spot. You'd say x equals 4. It would only touch the x-axis at positive 4. Or you'd say that the solution set is 4. But we've moved on now. We're going to do something called completing the square. And there are two ways to do it. The actual action of completing the square is a little different than what we're going to do first. And I'm going to create this video. We're going to do the easy part first, and then we're going to do the more difficult part. First thing we're going to do is, if we're lucky enough and we have perfect squares on both sides, or we can get to a point where we have perfect squares on both sides, or at least a perfect square in our quadratic, we are going to be good to go. So the first thing we're going to do is take our x squared minus 8x plus 16 equals 25. We're going to say, hey, both the 16 here and the x squared, they're perfect squares. And square root of x squared obviously is x, and the square root of 16 is 4. And we put them there. And, I just want to show you that this is the truth, and we don't have to worry about this 8x in the middle, unless it's some crazy number. What you want to do is you want to divide this by 2, and that should be your number here. So if you divide this constant by 2, you should have this middle term, the coefficient of the middle term. And like it says here, x minus 4 squared, if I actually FOIL that, and I'm just going to FOIL that for you, just so you see that it is indeed what you see before you. So we're going to do the firsts, x times x equals x squared. We're going to do the outers, which is x times negative 4, so it's negative 4x. And then negative 4 times x is negative 4x again. And of course, negative 4 times negative 4 is positive 16. And if we put these two middle terms together, we get our x squared minus 8x plus 16. And then we're, back to where we started. And that's what we were looking at here. So we're good. I think you now understand that I don't have to do any more crazy work for you. I think you can handle that. So let's go ahead and look at what happens on the other side. We have 25. Well, this is what we had. We have x squared, x minus 4 squared. And that's x minus 4 times x minus 4. So we have x minus 4 squared equals 25. Well, if we take the square root of both sides using what is called the square root property, means if you do it to both sides, you haven't changed the equation one little bit. So if we go ahead and say, hey, let's take the square root of both sides. Woo, whoopee. I know you guys are super excited. Well, that just gets rid of this square, so I just have x minus 4 on this side. Well, if I take the square root of 25, I have something that's not as intuitive as you might think. I know I have a 5, but there are two ways I could have gotten there. I could have positive 5 or negative 5. So when we take the square root of some constant that's over there on the other side, we have to solve for either of those two values. So now, because positive 5 times positive 5 gives me positive 25, and negative 5 times negative 5 also gives me positive 25 here. So I need to solve for both of those. And basically what I'm doing is, just like it shows up above in a weird fashion, right? It shows an odd fashion. That's what it should look like. That's the way mathematicians write it. Not like this. It's a little goofy looking. Why would we solve for a negative square root, right? Anyway, so we're solving x minus 4 equals 5, and we're also solving for, I'm going to say and, x minus 4 equals negative 5. Okay, well, this should be easy, and we should come up with the solution set that shows 9 and negative 1, and we will, because if we add, let's go ahead and use a different color, and we add 4 to both sides, plus 4. Now we show that x is equal to 9. Hey, well, there's our 9. All right, well, x minus 4 equals negative 9. We're still going to add 4 to both sides. And x is equal to negative 5 plus 4 is negative 1. Looks good. 9, negative 1, it checks out with what we see above. All right. The other one's a little bit more difficult, only because of coefficients. You guys hate having coefficients, but I'm going to tell you a secret. If you just look, if they're still both perfect squares, right? Because 4 is a perfect square, x squared is a perfect square, and 25 is a perfect square. So we know that this is going to work out, right? And then we know that 2 times 5, when we take that 2x and times 5, we get 10. 2 times 5 is 10. Double it, we get 20. If we looked hard, we could see it. But if you look at these outer extremes and you see that they're both perfect squares, just take a guess. And pretty much most of the time, especially for you guys, this isn't super complex math that we're worrying about right now. They're going to make sure that this is a perfect square for you. And so we break this down into 2x minus 5 squared, right? Remember, all we did was we take our lead term and our constant term, and we just take the square root of them, and then we look at this symbol right here in front of the middle term, and that's what becomes our operation symbol. So we have... and this is the more difficult part. It's this side over here. We have what in essence is 2x minus 5 squared is equal to 32. Well, 32 sucks, right? 32 is not a perfect square. There is a perfect square in it. Right, there's a 16 in it, so when we take the square root, we can find that and factor that out. When we take the square root, and I'm about to take the square root right now. Let's use this color here. We'll take the square root of this, and we'll take the square root of this. Obviously, this just gets rid of that square. So we have 2x minus 5. And that's going to be equal to plus or minus square root of 32. Plus or minus the square root of 32. Well, the square root of 32, and I'm going to do this over here. I guess I'll do it in a different color so we have this as a reference. The square root of 32 is the same as the square root of 16 times the square root of 2. Well, that's cool because square root of 16 has an actual value. So square root of 16 is 4. So plus or minus, plus or minus, plus or minus, plus or minus 4 times the square root of 2. And that's really what this ends up being. Don't worry about that plus or minus there. So this is 2x minus 5 equals plus or minus 4 square roots of 2. Well, this is pretty ugly. What we want to do is solve for x. And so we can go ahead and add 5 to both sides. We have 2x equals 5 plus or minus 4 root 2. And then all we do is move on. Now, we can leave this plus or minus here. This is a very, very advanced-ish mathematical idea, is to leave this here. You'll see it when we start using the quadratic formula. We just leave that plus or minus there unless we can solve. You know, if we have something that's irrational like this, 4 square roots of 2, we're just going to leave it alone. We can't solve for this. This is a decimal that doesn't end, and we don't care. So we still want to divide by 2 because we want to get x all by itself. So we divide both sides by 2, and we end up with x equals 5 plus or minus 4 square roots of 2, and the whole thing is divided by 2. And that's it, and that's how we got there. I'm going to move on now, and we're going to do a couple of examples that look like that. I'm going to do this and get rid of this, and that's, hey, hide that layer. I only want to be on this layer. So let's hide that layer, hide this layer, hide this layer. All right, oops, I hid the wrong layer. That's what I wanted to do. Here we go. Okay, so I still did it wrong, didn't I? There we are. Hey, look at that. It only took me an hour and a half to get where I wanted to go. So let's go ahead and see if we can take the square root of these ideas. We're going to ask ourselves questions, right? First question is this. Are these perfect squares, right? I'm going to jump over here. There we go. Are these perfect squares? Yes, this is a perfect square, and this is a perfect square. The square root of 100 is 10. 10 times 2 is 20. So we know this works out. What's the square root of 64? The square root of 64 is 8. So this, and this. They're all perfect squares. So I'm going to do a little bit of math, and I'm going to go ahead and take the square root of these guys. Let's use this guy here. Let me write it as that perfect square. Put a little square out here. Square root of x squared is x. We see addition here, so we'll put addition in. And the square root of 100 is 10. And that's going to be equal to 64, right? And now we're going to take the square root of both sides. All right, so let's see if I can get a root in there. Didn't give myself a whole lot of space, but it worked out. There we go. All right, so take the square root. All that does is gets rid of this square term here. So I have x plus 10 is equal to, the square root of 64 is plus or minus 8. Okay, so this can be solved because this is a rational number here. This is this number we can do the math with. So let's go ahead and solve these two equations. We solve x plus 10 equals 8, and x plus 10 equals negative 8. All right, and get rid of the 10 here, so we subtract 10 from both sides. And that goes away, and then x is equal to negative 2. And just like the other side we did, the other one we did, we subtract 10 from both sides. That goes away. And x is equal to negative 18. So if we wanted to write it as a solution set, we wanted to write our solution set, we'd use those crazy brackets. And I like to go from left to right, so negative 18 is farther left than negative 2. And we put those crazy brackets in. Okay? And that's basically it. Right? But, oh my God, what's going on here? We have a coefficient. But again, it's a perfect square, so we don't have to really freak out. And let's just go ahead and assume that this is going to be proper, a perfect square, right? Doubling of our square roots. Here we go. So let's go ahead and take the square root of 9x squared. The square root of 9 is 3. Let me use a different color. I apologize. Let me use a different color. Yeah. The square root of 9 is 3. The square root of x squared is x. Must be subtraction because our middle term has a negative next to it. And then let's go ahead and take the square root of 4. Now we have 2. All right, well, that's going to be equal to 4. Now we're going to take the square root of both sides. So go ahead and show that square root. Woohoo! So that just gets rid of that square. So again, we have 3x, and I have more space down below. I'm not going to try and squeeze it in here. Square root of 4 is, sorry about that, is plus or minus 2, right? Remember, we could get to 4 both ways. You know, negative 2 times negative 2 gives me positive 4. Positive 2 times positive 2 gives me positive 4. So we're there, right? With this one, we would solve these two equations, and there are a couple of steps that go with it. So I'm going to try and save myself a little bit of space. I'm going to write 3x minus 2 equals 2, and 3x minus 2 equals negative 2. So we'll start over here. Both of these equations, we add 2 to both sides. Right? And that goes away, and we have 3x equals 4. And then we divide both sides by 3. Let me go ahead and do that with a light color. Divide both sides by 3. And that becomes 1. And so this one is x is equal to positive 4/3. No need to change it. You can leave it right here as a fraction. That doesn't hurt my feelings at all. And then we'll go back to what we were doing before. And we'll go ahead and add the 2 to both sides. And this one's so much easier. That goes away, and we have 3x equals 0. Oh, forgot my x. And then when I divide by 3, well, x just equals 0 because 0 thirds is still 0. All right, so it crosses at the origin. All right, and that's basically it for the first page of this assignment. I'm going to create another video that shows you how to take care of the actual completing of the square, and it's got a couple of steps to it.